some of the experiment from virtual lab environment, and at the end we will discuss your queries. So if you have any queries, then feel free to ask. So first of all, the objective of this webinar is to give you an idea about the virtual lab, and we hope that at the end of this webinar each and everyone are able to get access and are able to perform the experiment from its own. So in this webinar, we give everyone to an idea of virtual lab and understand the working of the experiment. Okay. So the agenda of this webinar is to give you the objective of online labs. Then we will discuss the features, physical labs versus online labs, that when we have our physical labs, then what is the requirement to develop these types of environment. Then we will demonstrate the experiment from virtual lab platform. So first of all, what is virtual lab? Virtual lab is a project initiated by our Ministry of Education in 2009 under a mission, National Mission on Education through Information and Communication Technology. When we are referring the term information and communication technology, we are talking about internet. As you all know that in these days we all are connected through internet, and due to this logic, our government of India wants to enhance the learning process of our user with the help of internet. And to keep that in mind, Virtual Lab intend to develop a complete learning management system where the student can avail the various tools for learning, including additional web resource, videos, lecture, animated demonstration, and self-evaluation. It means we create a complete learning management system to our user, in which a user can get each and every thing related to that particular experiment on a single page. With the help of internet, we try to enhance your learning process. So the motivation behind our virtual lab is that you all know that India is a very diverse country in terms of physical as well as geographical condition as well as financial condition. There are so many colleges who are not able to set up the quality labs in their colleges due to geographical conditions. And there are some colleges who are not able to set up these types of labs, which includes sophisticated and costly equipments due to money constraint. So to overcome all these problems, we get an idea to develop our virtual labs. And also that if you have a physical labs in your college, then the maintenance and the updation of the instrument requires a lots of money. And in a situation like COVID-19, we are not able to access our physical labs, and we are not able to present it in physical labs physically to perform the experiment. So sometime cost, sometime physical distance, sometime money become the barriers between the experiment and the user. So to overcome all these problems, we get an idea to develop our virtual lab platform for our user to perform the experiment. So the objective of our virtual lab is to give you an environment in which you can perform the experiment virtually and to provide remote access to the labs in various disciplines of science and engineering to our user. As I told you that when you are not able to present physically in your college or in your lab, then you can able to perform the experiment from your own place, and also student learn according to their own pace. It means in virtual lab environment, we are working on a simulator, so a user can perform the experiment 1,000 times until unless he or she will not get the exact idea and rectify all the doubts for that particular experiment. So all these objectives integrated in virtual lab, so that on some day everyone must be on the same page. It means we developed an environment, a database for our user. So a user from different backgrounds can access the same database instead of their branch from their college name. They can access the same data and perform the same experiment. So a student from IIT, a student from NIT, and a student from private college, private universities, and a non-engineering background student can also perform and access the data and the experiment to learn something or to enhance their learning process. So as I told you that in virtual lab, we developed a complete learning management system in which a user can access all the data necessary to perform a particular experiment in terms of ebooks, videos, demonstration, interactive animation, some quiz, online feedbacks. So we try to cover up all the essential pillars of our learning system in a single website, virtual lab. On virtual lab, you can access all the theory, all the e-content, all the web resource on a single page. So a user are not have the necessity to go to some another website to access or to get the data related to that particular topic or to that particular experiment. He or she will or she get all the things on a single page on a single click. So as I told you that our virtual lab is a part of our mission entitled National Mission on Education through Information and Communication Technology. So the main portal of our mission is named Sakshat. So whenever our government of India comes with a new idea to enhance your learning process with the help of internet, first it will be uploaded and it will be reflected on our Sakshat portal. On Sakshat portal, you will find that our government of India running so many courses and so many programs for our users from to the very beginning from the school level to the post graduation level, and all these programs and all these materials are free of cost and available 24 into 7 on our website. So if a user really want to learn something, he or she will access our Sakshat portal and get each and everything what required to enhance or to learn something about their engineering field or science field or study parts. So you can access our Sakshat portal and you will find there are so many projects. Some projects are NPTEL, spoken tutorial and virtual labs. These are some programs comes under this mission, and as you all know that NPTEL is a platform on which the video and the theory content are available, and these contents and theory lectures are developed and uploaded by our expertise from IIT and some of the other colleges, and user can get the access of NPTEL free of cost and 24 into 7 and rectify and perform and learn free of cost on NPTEL portal and get the access of all the study material 24 into 7. And on spoken tutorial you will find software tutorial and software learning free of cost 24 into 7, and you will get certified from the government and become a developer in the open source software and technologies which are available in these days free of cost, and you can learn whatever you want on spoken tutorial, and the experimentation part will be done on our virtual lab platform. So here you can see some features of our virtual labs. As I told you that our labs are available 24 into 7, and you can access these labs at any time and from anywhere. Then we will have a very interactive interface and having a common web interface. So as I told you that you will get all the necessary information regarding that particular experiment on a single page, and you are not required to open some another website to get the information. So you just come on our website and you will get all the data on a single page. Then we will provide our virtual labs in a manner that you just required a internet connected PC, laptop or your mobile phone, and you can perform the experiment from any other branch or any branch what you want. And we developed our virtual lab in a manner so that a user from class 5th can are able to perform all the experiments, because you are just go to our website and click on some buttons and all the experiment performed by our simulator. So our virtual lab environment is very user friendly, and our front end and back end simulation are very user friendly and very easy to use. And when we are talking about the content what you get from our website, so I am telling you that it is very high quality content, because all the data uploaded on the website is developed by our professors, NIT professors, IIT professors, and the experts from their field. And before uploading the data on our virtual lab platform, it will go through so many quality checks, and after that it will upload it on our website. So you can rely or on our data what you get from virtual lab platform. Then here is the difference between the physical labs and virtual labs. As I told you that if you are going to set up physical labs, it will cost lakhs of rupees. But if you want to perform the experiment on virtual lab platform, you just require an internet connected PC, laptop or even a mobile phone to perform the same experiment what you are going to perform in your physical lab. So the cost of setting up a lab becomes almost zero when we are talking when we are perform these experiments in our virtual lab platform, because in this there are no real hardware involved, so we can update and there is no need of maintain these labs, so it reduce the maintenance and updation cost. So the availability, as I told you that you can access your physical labs with a limited time period, but virtual labs are available 24 into 7 and a user can access these labs whenever they want. Then the experimentation part. As you all know that we perform the experiment in physical labs in a very orthodox manner. And the innovation part, or we can say the option of innovation in the experiment is very limited. But in virtual labs, we provide some really good interface and very innovative things in our experiment, so a user can perform the experiment with curiosity. We provide some animations, some demonstrations, some quizzes, so it will make interesting for our user to perform the experiment. Then the user experience, as I told you that in a situation like COVID-19, when we are not able to get the access of our physical labs, then we provide the second best option. And if a user can perform perform the experiment before he or she will going to physical labs, then the percentage of error become almost zero, because a user get an idea that what he or she will going to perform in the physical lab. So here you can see there are our virtual labs get an edge over the physical labs. So here you can see our broad areas, and till now we developed our virtual labs in these areas, and we are working day and night to integrate all the other branches of engineering and science and arts also, and try to get each and every experiment which are running or study in different colleges across the country on our virtual lab platform, that one day each and every experiment are available on virtual lab. So to achieve our goal, here you can see the list of our participating institutes. There are some IITs, some NITs, and some private universities are working together to achieve our goal of our virtual labs. Here you can see the simulation, a screenshot of our experiment in which we give our user a 3D environment, and this environment is used to perform the experiment from a surveying lab in which a user can roam around through the environment and take the reading according to the instruction and perform the experiment online. And we provide these types of simulation of our user, so a user can make the corrections, draw a circuit, take the reading and plot a graph according to that reading and complete the experiment. And as I told you that in virtual lab platform we are working on a simulator, so if you make some wrong connection, there are not worry of wear and tear of that particular instrument. You can perform or you can reconnect our connections 1,000 times. So the national impact of our project is that till now we developed around 1,300 nodal center across the country, and around 2,300 workshops are done till date, and there is a large number of participating users and participating attend these types of workshops across the country, and we will try to achieve that. We will try to integrate all the colleges across the country and make each and every college a nodal center of our virtual lab project. So here you can see we can get daily analysis of our labs, so that we can rectify and provide a better experience to our user and make an environment where a user can perform these experiment with ease. You can see the statistics that from top 10 experiments, 8 are coming from the IIT Roorkee, and we feel proud on it. And here you can see the statistics of our virtual labs. And now the interesting part, that how you can perform these experiment. As I told you that you just require an internet connected PC, laptop or a mobile phone, and you just type the URL www.vlab.co.in onto your search box, and you will get the first page of our homepage of our website. And you can also access our virtual labs through Sakshat portal also. So the intended user of our virtual lab is the students from the colleges who are not able to like setting up, like they are not able to set up a physical lab for the curriculum what they teaching in their colleges, and the researchers who want to like share their expensive equipments and resource, and the students from school or the student from the school level uh, can perform these types of labs and make up their minds for their future studies. So as I told you that here you can a user are free to perform the experiment from any branch. So we also emphasize on self-learning and as well as interdisciplinary mindset also. So we try to make our user self-dependent and interdisciplinary mindset. So till now, if you have any query or any question, just feel free, or we can move to our demonstration session in which we give you a detailed introduction that how you can access our virtual labs and perform the experiment. So student, are you have any questions, query related to Virtual lab, please feel free.
Yes, sir. Sir?
Yes, yes, please.
Sir, I'm Harshpal Singh.
Yes, please.
Sir, I did not understand the Sakshat portal, online
Yeah, the
portal, that
Sakshat
one, sir.
portal. Okay,
Yes,
okay.
sir.
See, as I told you, that virtual lab is a part of a project.
Yes, sir.
Okay, and the project name is National Mission on Education through Information and Communication Technology.
Yes,
So
sir.
it is a part of a project, and the main website of that project of that mission is Sakshat. So here you can see there are so many projects for school students, from graduate students, from undergraduate students, and here you can see all the links like I explained you earlier: spoken tutorials, NPTEL, virtual labs. There are so many projects which integrates the students with the help of internet and provide the study material and interactive way to learn. Okay.
Yes, sir. So one thing, sir. Sir, we can access the virtual lab via Sakshat online portal, right, sir?
Yeah, you can access
Yes.
from Sakshat portal also, and the the URL vlab.co.in is the direct URL. You can access our lab from Sakshat portal also,
Okay,
but
sir.
yes, this is the direct link of our website.
Yes, sir. Clear, sir.
Okay. So here you can see our home page, and here you will find that there are so many tabs: our objectives, our broad areas, our participating institute. Here you can see which labs is developed by which institute. Okay. VLab Dev. This is the portal on which the lab developed by our Noodle Center students are
Okay.
uploaded, and then we rectify all the mistakes and all the getting the feedbacks from our experts, and then we will upload the approved lab for to our main portal. Then we will have our outreach link also. Here you can see the upcoming workshops and the workshops data. Okay. So I think you are from first year. All the students are from first year also. Only you are from first year, na?
Yes, sir.
Yes.
Okay.
Yes, sir.
So we are going to perform a very simple experiment. I think you all know and you all study the Omslo in your school or in your college days. Is I'm correct?
Yes, sir.
You all know about Omslo? Okay, so if you want to perform Omslo, yeah, please switch off your speakers. So here you can see the broad areas, and to perform the experiment Ohm's law, you just click on the electronics and communication tab. You can perform any experiment from any branch, but this is a very simple experiment, so I start from this. Here you can see the broad areas and the link electronics and communication. You just click on the tab, and you will find there are so many labs available here. We are having around 250 labs and around 1500s of experiments. So you can perform, you are free to perform any experiments from this. I'm just giving you idea that how you can access these labs. So here you can see the link basic electronics lab. You just click on the lab, basic electronics lab. It will take some time to upload. So you just wait for it.
So basically, this is the first page of the Electronics and Communication Engineering Lab, and this is the Omslo experiment. And in this particular experiment, what we have when we move to this experiment, we have the 7 different ways to perform this experiment. The Ohm's law. In this Ohm's law, we have the combinations of our required equipments like voltmeters, ammeters, resistance, and all the things. And in the second part, we have the components, but we have to make the connections of these and other variations also. So this is the complete theory about this particular experiment. If you want to check the theory or just recap your knowledge, just go to this theory part and read out carefully. After then, we have the procedure part. So this is the complete procedure. Now, this is the simulation part. And in the simulation part, what we have, Ohm's law. When I click to the Ohm's law, this page will open. So this is the first part of experiment. Like for the students who do not know about the working of this particular experiment and how to perform this experiment, so we have an instruction tab for them. So just click on the instruction tab. So each and every instruction is available here. So now in our Ohm's law circuit, what we have the power source here, the VDC, then we have ampere meter, and then the resistance and the Ohm's law. So this is a complete circuit of the Ohm's law, and we have to make the we have to take the readings on the basis of our inputs. So what we are going to do in this particular experiment, we fix the value of our resistance to a particular value, and then we will just change our DC voltage. And for different DC voltages, we have to calculate our current. So what is the procedure? I'll fix my current value to the 1 ohm initially, and then change the value of DC voltage. Like for 1 DC volt, what is the value? What will be the current? I'll click on the add to table button. So for 1, the current is 1 milliampere. Then I'll change the value of DC voltage to 6, and then click on the add to table button. And I have to take 4 to 5 readings to create a proper graph. So after taking the readings, I'll click on the plot button. Once I click on the plot button, a graph will automatically plot it, and you can check the graph also. And also we have a print button here. So once I click on the print button, it will take the screenshot of my page and give you the printout, or you can save this printout as a PDF also for your future references. So basically, this is the first experiment of Omslo. Now we will try to perform the experiment, the second experiment, which is also similarly the Ohm's law, but in this we have to make our connections at our own. So when I click to our second option, the Ohm's law, so we have a components available like resistance, the voltage source, the ammeter, and the voltmeter also. So in this particular experiment, what we have to do, the procedure is completely same with the previous one. But in this part, what we have to do, we have to make the connections first. Once we make the connections, then we will check the connection that whether the connections are right or wrong. And if the connections are correct, then we will move to take the readings in the field. And if the connections are not correct, it shows me that the connections are correct. Please check. Not correct, please check. So I'll make the connections. Just give me a second. And click on check button. So it shows that the wrong connection because the polarity of my ammeter is different. And I click on, now I again reconnect my ammeter with the proper connection and shows that the check button, connection button. So it shows that the right connections. Now once the connections are right, my add to table button is active and I'll change my readings and perform the value. So initially what I have to do, I'll fix the resistance value, any of the resistance value, like choose 20, then apply the DC voltage and click to add to table. Now again, so for a proper graph, I have to take 4 to 5 different readings and click on the plot button. Once I click on the plot button, the graph will automatically created with the VI plot. And once I click on the print button, it will take me the printout of this experiment. So this is the experiment on the Ohm's law. Now we have some another variants, like what will happen if the resistance is in series, then make the connections also for the resistance in series, then the resistance in parallel, and for the door connections also, and verify the non-ohmic device like diode. Now we have the quiz. So this is the next part of our experiment that you have to complete the quiz available here. So please check that at your own. And we have the assignment also. So this is the assignment for you guys in this particular experiment, or you can take the printout and solve the answer and submit to your teachers. Then we have the reference here. So this is the complete reference from where we taking these all the things. So this is the first experiment of virtual lab. So I hope you get the idea about the virtual lab, that how you are going to use these experiments and what is the procedure of performing these experiments. Once again, I repeat the task, that what we have to do initially, we have to move our URL, that is www.vlab.co.in, and then from the broad areas or by the participating institutes, we just move to our required experiment. Like if you want to perform the experiment from computer science, just click on the computer science and check out the experiments available. For now, I'll click on the electronics and communication, and this electronics and communication engineering department contains these different laboratories available. So you can check these. Now, as I click on the basic electronics lab, so this is the basic electronics lab available. The list of experiment. Now we have a next experiment on our rectification, like half wave rectification and the full wave rectification. I'll click on the half wave rectification. It takes some time to load. Meanwhile, we'll just check the another laboratory, uh, like digital electronics lab. So this is the lab which is developed by IIT Roorkee. So we click on the digital electronics lab, and again we have the similar process here. List of experiment. So we have 12 different experiments available in our this laboratory. And the first experiment is the verification and interpretation on truth table, and then gates, the half adder and full adder, the half adder and full subtractor, the flip-flops, and each and everything is covered here. But for you, as you are from the first year, the first experiment is from your syllabus. So I'll click on this particular experiment. Initially, what we have the aim of this particular experiment. So what we are trying to do, that we just copy the process of actual experiment from your laboratories. Like once you move to your laboratory, you got the lab manuals, and in the lab manuals you have all these things like theory, the procedure, the graphs, and the other things. So each and everything is available here. So I'll click on the theory part. So this is the complete theory for this particular experiment. Like the introduction, in this what we covered the AND gate, OR gate, NOT gate, NAND gate, NOR gate, XOR gate, XNOR gate, and then the complete theory about these gates. Like initially what we have, the truth table of gates, then the logic symbol of the gate, then the OR gate, the truth table of OR gate, then the NOT gate. So each and everything is available. You just recap these things from here. Then we have the pre-test. So basically, in these experiments, we just design the experiments with the help of two types of tests, like the pre-test and the post-test. So in the pre-test, some easy questions from your syllabus is available, from this experiment is available, and in the post-test, some higher level of questions are available. So I'll click on the procedure. So this is the complete procedure for performing this particular experiment, and then we have the simulator. So if you are the first time user, just go to the this procedure part and check out the procedure carefully to perform these experiments. So this experiment we divided into two parts. We make the two simulators of this particular experiment. Like in the first part, what we are doing, we are just working on the actual kit which is available in your physical laboratory also. While in the second part, what we are doing, we just cross check our just a second, guys. So in the second simulator, what we are going to do, we just create the environment, like you have to give the input as well as the output. If your input and the output combination is correct, it will shows you that the answer is correct and give you the notification. Like I click on the simulator and click on the AND gate. So this is the first simulator, and then we have a second simulator. Similarly, what we have the instructions part here. So this is the complete instruction for this experiment. Then what we have the symbol of our gate, AND gate, and we have to provide the input as well as the output. So for this combination, I provide the output as 0 and click on the check button. So in this combination, it shows me that the answer is incorrect. So you can just recap your things about the truth table, about the gates. And then if I press the value of 1 and click on the check button, it shows me that the answer is correct. So I'll verify my truth table for all the possible combinations for the two values. So this is the complete truth table for this particular AND gate. And then we will move to our first simulator, the simulator 1. So this is the exact replica of our experiment from the physical laboratory. Like we have this kind of the kit which is uh, work with the help of the NPN transistors, and we create this kind of the thing. And the red value shows that the shows in this particular experiment the flow of charge in the circuit. So I'll click on the battery button, and once I click on the battery button, it will connect to the circuit and then switch on the power. Once I click on the switch on the power, then it will shows the flowing charge to the green. So the green charge shows that the current is available at these particular points. So these are basically the two switches for the input, the values of A and B, and then we have the output in the form of our LED. So for the combination of 1 and 1, the answer is 1, and it shows that the LED is glowing. For the combination of 0 and 1, the answer is 0. For the combination of 1 and 0, the answer is also 0. So these kind of the experiments are only for the first year students, and for the basic experiments. So each and everything is on the basic experiment. And you also have the higher level experiments also available in these labs, like digital signal processing lab. You have like venturimeters experiment for fluid mechanics, for soil mechanics also, for surveying engineering lab also the experiments are available. and I'll show you some another lab. Just give me a second. So just give me a second. Yeah, this lab is available now. So for the half wave rectification, what we are going to do, the rectification part in this particular experiment. So this is also available in your basic electronics experiments. So initially what we have the theory. So this is the complete process of the half wave rectification. Like for a sine wave, the half wave rectification will block the negative half of our sine wave and only provide the positive half values. And in case of the full wave rectification, the negative value is also present in the half wave, in the positive side of the output. So this is the complete, this is the half wave rectification waveform. So this is the complete sine wave available in at the input, and this is the output. The positive pulse is available in the same way, while in the negative wave, the negative side, the negative pulse is as a DC mode, that is 0. So this is the identical way. So I'll give you the procedure. So this is the complete procedure to perform the experiment. So this is the calculation you can check. Then we have a simulator. So simulator, I'll click on the half wave rectification. Just a second. So it's taking too much time. Don't know why. Just wait for 2 minutes, and if not open, we will move to another laboratory. It's here. So in this particular screen, what we have initially, we have the instruction part. If you don't know how to perform the experiment, the instructions are available here. Then we have an oscilloscope screen, so it will give you the input as well as the output waveforms here. Then in the bottom part, what we have our controls. In the right hand side, we have our circuit. Then we have our controls of our oscilloscope. Let me give you the brief way to perform the experiment. So what we have, firstly, we have to set our resistance value, the RL value, any of the value, and then click on the power button, power on button. Once I click on the power button, the oscilloscope screen will open and the circuit is available. I'll click on the oscilloscope button, the sine wave, and the oscilloscope. So in this particular experiment, this is our oscilloscope output. We have the channel 1. This is for the input. For channel 1 controls, what we have, this screen is of our channel 1 control. This is for the Y position shifting. Then what we have to change, this is for the amplitude change. The clock value of our oscilloscope will vary from here. Then this is to change the frequency. So this is the frequency of our input signal. You can change here from here, and this is for the amplitude. These are the controls available here. Now we will move to our second channel. So this is the second channel. Basically, the second channel is for output. So the second channel control is for here. So this is for the Y channel control, Y level control, and this is for the divisions control. And this is the X position and X position control, and with the time division also. So this is the actual answer of my peak current from this experiment. So you can change the frequency, the amplitude from here, and the ground is available here, and the dual is also available here. So this is the dual value for the answer. So this is the way to perform the experiment from the rectification part of our electronics engineering. So I hope you guys get the basic idea about how to perform the experiment and what is the working of the experiment. Any guys, if you have any query, just please ask.
Yes, sir.
Yeah, please.
Sir, in the Ohm's law circuit one,
Yeah,
yeah, sir, in that one, which one will remain constant? I thought of asking the question at the end.
yeah. When we performing this Ohm's law experiment, the constant is resistance.
Sir,
The
not
res
this one, sir. So the next one in which we connect the wires.
Okay,
Yeah, so
so
that one, sir.
that is also the same process. The
Okay, sir.
experiment is same, but the difference is that in the first part, what we have a predefined circuit available. But
Yes,
in
sir.
the second part, what we are going to do, we just create the circuit with the help of our components. So in
Okay,
this,
sir.
what you have to do the connections. While in the
Yes.
first part, you just taking the readings.
Yes, sir.
This is the difference.
Yes, sir. Clear, sir.
Yeah. Any other? Any other guys? So we are just giving you the demonstration of easy and simple experiments to you guys. But you have the chance to elaborate each and everything. More than 250 different labs are available on the virtual lab platform. And if you are from the computer science engineering, you can do that also. From that in electrical engineering branch, from mechanical engineering, and you also do your experiment from chemistry that you are working with the first year guys. Like in the chemical science, you have the inorganic chemistry virtual laboratory, and these all the experiments are available in your curriculum in first year. Most of the experiments are available, like the acid-base titration, the determination of pH, and the physical parameters, the pH, the electrical conductivity, and all the things are available here in this particular experiment. You can check this also. So anyway, guys, this is all from IIT Roorkee side, and if you guys have any query, just please ask. And if you just want to share something about the virtual lab, you can do that also.
Any feedback, students?
Yes, ma'am.
Yeah, tell.
Ma'am, the class was very good, and we understood a lot of things. And for coming to the merits and demerits of the virtual labs, uh, virtual labs are very much, ma'am, innovative, and we can access any experiment in the online platform, which and some of those experiments might not be available in the physical labs or in the physical condition. And ma'am, in looking at the today's condition, we are very less exposed to the virus. And yesterday we saw, like, in the newspapers also is coming that virus has been climbing exponentially. And virtual labs are very much economic, cost efficient actually, because it's only, or the only thing which is required is a PC or a mobile with a good internet connection. That's it. Yeah.
Yeah, thank you, Harsh. Okay, anyhow, I already shared feedback link. Please fill the feedback form. I'm sharing once again. Please fill the feedback form. After half an hour, I'll disable the link. Okay. So within 30 minutes, you please fill the form. You will get your certificate on your mail ID. So please write correct name and correct email writing. Okay. So Amit sir and Chetan sir, thank you, sir. Thank
Thank
you
you,
for the
ma'am.
session.
Thank you so much.
Yeah, thank you for the session, sir. Okay, sir. We'll meet tomorrow. No, no, day after tomorrow.
Day after tomorrow. Thank
Bye,
you.
sir. Bye, sir.
Bye, ma'am.
Excuse me, sir.
Excuse me, sir. Excuse me, sir. Excuse me, sir. Sir.
Sir? Excuse me, sir.